Now let's take a look at example 3. We're asked to simplify some radical expressions, and there's two ways we can go about doing this. One way for part A, and hopefully for square roots we can do it like this, is somewhat of an intuitive approach. Let's think of factors of 32. 1 times 32, 2 times 16, 4 times 8, and that is it. You see we have a number of factors here. Now let's look for the largest perfect square factor. And 16 is the largest perfect square factor. So we can call this the square root of 16 times the square root of 2. Well, we all know that the square root of 16 is 4. So 4 times root 2 is our simplified answer. Now, if you're struggling with that method for some problems, maybe there's a larger number and we're not quickly coming up with all the factors, here's another way we can approach a simplifying radical problem. We can take the square root of 32, and what you got to recognize is that the root index here is not written. It's invisible. We didn't write it. But that's really a 2. We're taking the second root, or the square root. So keep that in mind. Now what we're going to do is we're going to list the prime factorization of 32. So we can call this, let's see here, 32. We can call that 8 times 4, 8. We can break this down into 4 times 2. 4 can be broken down to 2 times 2. Here we go, another 4 can be broken down to 2 times 2. Now we have all prime factors, 1, 2, 3, 4, 5, all prime factors. Since the root index is 2, we can think of it like this. It takes 2 common prime factors to go out. There's a pair of 2's, so we can write a 2 outside the radical. Here's another pair of 2's. The root index is 2. There's 2 prime factors that are in common, so we can bring out another 2. And, of course, here's one lonely 2 with nobody to partner with. He's not going out, he's staying inside the radicals. 4 times root 2, same value. Now, the reason it takes a pair of 2's to bring something outside the radical is because here we have 2 squared. Well, you all know that the square root of 2 squared is the square root of 4, which is simply 2. That's how we pulled out this first 2. Similarly for the second pair of 2's and so on. So hopefully this was helpful. Let's go take a look at part B. Part B, you have to notice now that the root index is 3. We're taking the third root of 128. Most people aren't going to do this one mentally really quickly, so let's list the prime factorization of 128 and see what we get. We can call this 4 times 32, 2 times 2. We got prime factors, so we'll stop there. And we can break down 32. 16 times 2, 2's prime, we'll stop there. Break down 16. 4 times 4. 4 times 4 is 2 times 2. Now we've got all prime factors. We can go to work. Now, the root index is 3, so it's going to take 3 common prime factors to pull anything outside of the radical. So here we go. Here's 1, 2, 3 factors of 2. So when we're simplifying our radical, we can pull that 2 outside. Here we have another 3 factors of 2, so we can pull this 2 outside. And we're left with 1 solo 2. It's like a 3-on-3 basketball tournament. To get a team, you need three players, so we need 3 factors of 2 to pull out. This solo factor here can't make a team, so he's staying in. And if and this is a third root. So when we simplify this expression, we're going to get 4 times the cubed root of 2. Now this doesn't seem as intuitive to us, so let's just double check our answers. What we want to do is use our calculator to help us check our answer. Our original problem is 128, cubed root of 128. So we're going to type that in as 128 raised to the 1/3 power. So we get a long decimal, 5.0396842. That keeps going. We know the calculator only shows this many digits. Now let's type in our answer. 4 times, and now we want to type in the cubed root or the third root of 2. So we're going to use 2 to the 1/3 power. When you hit enter, you see that these values are equivalent. So we're sure that we did it right now, and we can go on to the next problem. Hey, thanks for watching the video. I hope it was helpful. If you have any questions, bring them into school, and I'd love to discuss these problems further with you. Good luck on your practice problems.